Hello everyone, my name is Aras Awar. I'm the student of Electrical and Electronics Engineering, and today I want to talk about wave side of light, which scientists thought that light was a wave and explain with their theories. So, what is light? Light is the connection between us and the universe. It's not just what we can see. Light can be broken up into different types, and we call the whole family the electromagnetic spectrum. And when it's dark, light is still all around us. Light can be created by making an electron oscillate. This creates an oscillating magnetic field and an oscillating electric field, which we call electromagnetic wave or light. We often represent light as a wave, just like water waves. Light has a wavelength, a frequency, and a speed, and the gamma rays are the most energetic waves, whereas radio waves of the least energy. And light is the fastest thing in the universe. In a vacuum, all light waves, even radio waves, travel at an incredible speed. And it's 300 million meters per second. As light was a wave, there are some physicists and scientists with their theories about light wave, and I want to share them with you. And the first person is Christian Huygens. Christian Huygens was a 20th century Dutch physicist who believed that light acts as a wave. He came up with a way to predict how a wave will spread out, and we still use his method today. Huygens' principle says that you can predict wave's position in the future by analyzing its current position. All we have to do is think of each of point on the wave as the source of its own linear wave. So look, Huygens knew that when you multiply the velocity of something by the amount of time it's traveled, and you can figure out how far it went. And he figured that this would also be true for each individual point on a wave. So let's say you have a wave that's traveling 10 centimeters per second, and you want to know what the wave will look after 2 seconds. To use Huygens' principle, you first draw a bunch of little points along a wave. Then you draw a half circle around each point in front of the wave with a radius equal to the wave's velocity multiplied by time. So 20 centimeters. Each of those little half circle is called a wavelet. Finally, you draw a curve that's tangent to each half circle at exactly one point. That line shows the location of the waves after 2 seconds. So a two-dimensional wave traveling through empty space will look pretty simple. It's basically an expanding circle. But the things get a little more complicated when a wave hits an obstacle. For example, let's apply Huygens' principle to a wave that moves past the edge of a flat object. When the wave hits the obstacle, part of it gets blocked, but the part that isn't blocked keeps moving past the edge, and it follows Huygens principle, forming wavelets. The wavelets from the part of the wave near the edge will curve behind the edge, and when you draw a line to connect all the wavelets, you end up with a line that bends around the edge. In the same way, when a wave moves through a slit that's roughly the same width as its wavelength, it travels past the slit in a circular curve that spreads outward. When waves are reshaped by obstacle, that's called diffraction. And as you see, the shapes step by step. Diffraction is one of the reasons there is a bright spot in the middle of the shadow when you shine a light on a round object. The other reason is interference, and I want to describe what happens when waves run into each other. They interfere in one of two ways. Waves interfere constructively when the crests of both waves end up in the same spot, and so do their truth. The waves essentially combine into one wave that has a larger amplitude with higher crest and lower trough than either of the two waves did before. But waves interfere destructively when one wave's crest run into the other wave's trough, and also vice versa. In that case, the combined wave has a lower amplitude than either of the waves that did before. With perfectly destructively interference, the waves actually disappear completely. They flatten out, as you can see their figures on the slide. Together, diffraction and interference help explain the results of the famous double slit experiment conducted by English physicist Thomas Young in 1801. Young covered a window so that only a very narrow stream of sunlight passed through a slit into the room. Then he positioned a plate with two more tiny slits cut into it, spaced very close together so that the single beam of sunlight passed through them. Finally, he placed a screen behind the slits. If light were just a stream of particles, you would expect to see two bright lines on the screen behind the two slits. But that's not what Young saw. His screen had many lines on it. There was a bright line in the middle, then more bright lines above and below it. This pattern is called a diffraction pattern, and it comes from the diffraction and interference of light waves, and that's all. I hope I can give benefit information about light, and scientists that they thought the light was a wave, and thank you. Take care of yourself.